When Elon, when finally the Falcon 9 was announced, and we could see pictures of it on the computer and through the net. Last year, Robert Zubrin said that a mission for two using the Falcon 9 was possible. And so I thought to myself, well, let's just see if that's true, and I tried to sort of figure things out. So we can go through the abstract real quick. It's basically saying the same thing. We'd be using new technologies, and ones that are being formed right now, off-the-shelf technology, Falcon Heavy. If we can stop on this one, we can see, I think you gotta go back.
Yeah.
Okay, one more? Oh, no. Go one more. There you go. We can see that we're looking at X-Core. We're looking at, we also looking at Paragon Aerospace and a lot of their products here, but they're not giving us a lot of information on mass and or volume. So we have to extrapolate and make guesses like that in order to move forward. So we can go to the next slide then.
Okay.
Go ahead.
Another.
This is the Oregon Trail. And the reason why you see these lines here is not because four-wheel drives are driving on it. It's because they're there from wagons over there. Next one. Another shot there. There's the Boise River Valley. And this gets very light foot traffic, but they're still there. We're going to go into the signs now. Next, please. I don't know if you can read this, but there's things like 3 rifles, barrels of flour, coffee, 100 pounds, lard, sugar, you can read it now, rice. There's some things you want to carry along with you, and we'll go to the next one. Keep it zoomed in, too. You must have double skipped. I think you skipped. Okay, this is fine. We can still read this. Here's more stuff. Shirts, socks, a pound of Castle soap, 3 pounds of bar soap for the laundry, wool shirts. This is all published by, it's all on the trail. The next one is the most important, however. If we can read, if I'll just allow it, can everyone read that if we can zoom in on that? I didn't realize when I was first going there that every mile I walked on there were 10 unmarked graves along the Oregon Trail. And a lot of people turned back. So back with Apollo, no one published that it was a 50-50 chance that Buzz and Neil could make it back. So it's chancy, and I think that NASA and other groups have just got to get some cojones, as someone said last year. Well, they said it last year, so I figured it's okay. We're not focusing on the half. This number 14 is wrong. It's supposed to be 12 and a half. But just to show you how much space this uses, the shield, this type of blunt thing that Robert designed. All of the mass goes near the bottom. A little bit more mass in here, and then here's just a bed, 2 bedrooms and a bathroom up top. But it's huge. It's 15 feet across. It actually would be overall smaller, and we would not be using this giant arrow shell. And next. Okay, this is the thing that's real plus about it, because we're making the design of the vehicle, of the ERV, is already aerodynamic. We don't have to use this. The nice thing about it is, I don't know why it's not showing, we can add 1,750 kilograms more to what the launch weight is of the Falcon Heavy, which is 29,101 pounds. So 1,750 kilograms. It's a huge amount of weight that we can play with. I'm not using it for this reason, but I'm sure a lot of people, hopefully we can get discussion because people are going to find mistakes and stuff. Next, please. Dragon, but we're not going to use the Dragon 2. And this has a lot of fuel on board, in big thrusters because it was meant for a cargo carrier, and there's a lot of orbital maneuvering with a lot of mass. So it carries a lot of fuel, and it's got big thrusters on board. But everything else, it's got the heat, it's got the radiators, it's got all of what we call for in Mars Direct. It's got the big trunk underneath here. And we can make more space inside the capsule because we're getting rid of all of those fuel canisters, or a great number of them. Next. There's the general shape, 1 meter. You can see the top in there. This actually I drew in. This is actually too big because on the way here I got an idea. Some people, you know, they just can't stop thinking. We'll go to the next one. Okay, there you are on the Martian surface. It's got a different landing gear. Of course, this doesn't say Mars Direct on it. This isn't popped open where the chutes would have already gone out. And what is called a para-shield, which only goes across this area, has already been dumped off. And we can move on to the next. These are the large areas right here. We have those fuel canisters and the pressurized helium. Really a lot of space. We can cut those down probably all the way right to here. A lot of people aren't aware that Apollo only had 200 pounds of propellant. They just had to turn around and they had to use the rest to keep the right attitude as they were sort of gliding and diving through the atmosphere. So we see all this volume in the payload. So by moving this away, we're going to go to the next slide. Actually. Here's just some of the Dragon specifications. Has anyone seen this before? There's a lot of goodies that are already on there. We can go ahead. Okay, this is what I want to exploit. You see all of this space here, including this, and you've got this docking ring here. But we're not docking to anything. So we'll go to the next screen, please, or the next slide, please. This is a great illustration of how much space is being used. One of these is the helium, the high pressure helium. And then you've got the two, are they hypergolics? And then I don't know, I'm not exactly sure what they have in these particular areas. A lot of space. Next, we'll show more space again. Look at the space here. Again. Once again, with a little bit more of the capsule put together, still seeing all this wasted space. We would cut all the way across down to here. So we've got the Dragon has 10 cubic meters of pressurized volume in it. And we're talking about bringing it up to 15. Okay, next. This is really good illustration showing these two seats here. What we would be doing is right along this line as we'd make another, it would just be a little separator. We go up 1 meter, which is about right here, to that here. And this is your berth, a full meter. And this also has all of your polyethylene, which is filled with water through here, including the hatch. So when you have a situation with radiation, both of you climb up in there and you watch, I don't know, The Man from Snowy River, or something like that. You both have your separate monitors. And I would recommend that people work on 2 shifts. One person's on, so they're down, the other person's up sleeping. We don't want anybody to have a psychotic break on the way. So, next. This is when I had the idea, when you see how this is built real big. Well, we can nix that because I realized that this is about 2 meters right here. And we're only going to have no one greater than 5'10". And they're going to have to stand in there with their suit on. So it's going to be a little bit taller, and our berth goes right across there, and we're going to have a blunt rounded area because we're going to be taking off from Mars with the blunted. We're going to have the regular one here, the regular cone, because there's going to be steel bars here, of course, that are reinforced because all of your parachutes are going to go here for your deployment on Mars. Next, please. This is when we got rid of all of that space on the bottom. So you've got almost 8 feet across here, And these are desks, if you do spin it up, and there's a window at each desk. Those chairs that you saw earlier are going to be changed a little bit. There's going to be four posts on them. Some of the lengths are going to be changed to where they can be bent and made regular chairs out of them, so that they've got a dual function. You can take off in them flat or semi-recumbent position, and then just sitting here. There's your hatcher. And next, please. Okay, there it is. Once again, this has been cut down in size. Your deck is there. You have 2 drogue chutes, and you've got 2 high-speed drogue chutes, and you have 3 Mars Science Laboratory chutes. And I don't know if they will work together. They might collapse. That's what you need to do to slow it down to the speeds that Robert has been Dr. Zubrin's been talking about in the book. Life support, H2O, and here's your RCS here for, of course, we're missing our cruciform, and it's not just cruciform, it's a 5-way, so that you have one facing out. You have up, down, toward, back, and then out. And I'll explain why. Oh, this is your, there's the rover down there with the reactor. There's the fuel supply. This is hydrogen right here. There's the 3 X-core engines, and there are 3 saddle tanks here with hydrogen in them with multi-purpose uses. Next. There's Robert's design, or Dr. Zubrin's design. I took it upon myself to measure some things out, and I drew it from a side view, because it makes these look really long when they're not. Go ahead, next, please. And that's what it sort of mostly looks like. But it gives you the full 23 meters. What he called for his full weight. You'll look at this, you're going to see the full weight for the ERV. Next, please. Okay, we no longer have the arrow shell. We now have what's called a parashield, and we'll have some more. This is light, and it's also very safe. Next, please. This, if you can read that, maybe you can zoom up on that for me. This is important. This only weighs 750 pounds or so. Sort of like those things that you have for the fireplace. You bend them out like this, and you grab the log. It's exactly what it is, but they're off center here by minimal, so it creates an arc. And you have all of you have multi-layered insulation in your carbon, woven carbon on the outer for the heat. And next, oh, this is the important thing here, is you've got, this is what it was tested at, so that's megapascals. And the safety margin, why is that not showing on there? Can we unzoom that a little bit? Zoom out. Yeah, zoom in. There's your safety margin, really high on this design. It's going to require more development, obviously. Next, please. Here's an image of it sitting in the with ERV sitting in the parashield. And remember, we have our great deal of our mass is down in here, and that's why we have a more. If you look at your handout, we have once again, I didn't show the cruciforms. This is why we have to have this extra RCS here, so that we can pivot as we steer down in. So we capture and then go down in. There has to be pivoting along this base point here in order to keep control as you go down through the atmosphere. Next. Just this whole series of different designs, that are out there: tension cone, trailing torus, inflatables, I mean, you name it. This pretty much is deployable rigid is Dr. Zubrin's design. Semi-rigid deployable. I would say that the parashield is somewhere between here and here. This is for when you're flying in and you're leaving the arrow shell home, or the. We can go to the next. Thank you. Just another shot of it. There's the tension code. Go to another. Flying torus. Go ahead. Okay, there's the MLS parachute. 65,000 pounds of drag. I believe they said it only weighed 120 pounds. I was shocked. Okay, next. And we would be using 3 of those of similar drag to bring this in after the 2 drogues are used to slow down and we could deploy. This is the total weight that came in. So you got 8,000 pounds, but this is what the parachute was set at. So in order to get it to come down really slow, you have to have a lot of parachute, a lot of area. Next. Okay, if you're in the Commonwealth countries, these are Super Draco engines. I think in the United States they call them Super Draco engines. I'm not sure. But we're going to use 3 of these at the very bottom of the ERV, and it's a total weight of 900 pounds. Next, please. Firing Super Draco. Next. That's another Super Draco image. Next, please. Okay, landing. This here. I've got 2 different images, a quarter view and a straight side view. The question here is whether or not these would create a problem with drag, since it's an aerodynamic shape that we're sending that. If there would be because your supersonic shock is going to come out here, that there might be an additional one here, and I don't know how much, if we're going to have an envelope here where that's not a problem. But they're real.
It does get warm, but not that hot.
Okay, these are the landing legs, and they're designed. Everyone's seen landing legs on the Falcon 9. Next. Okay, or we could go with this. That's right off of Mars Underground, and we have the space on board the ERV to use those. We could go with 5 of them. Next. Okay, once again, this space right here, just above the fuel tanks. This is where that style, we can stop there, that's great. When I just showed you the half that was coming down, this is where these would come out, and fold out and drop down. And you could probably do 5 of them, and there'd be enough room for the rover to come out. Once again, let's not forget there's 3 tanks in here, and I'll show you a different view of it. Okay, next please. Okay, that's at the base of the nozzles there. You see these? Now we could get them closer to the nozzles, but they carry about 18 cubic meters of fuel, of hydrogen. And then the other, what's 18 minus 44? Or 42. We're using a little bit less because we're not using fuel for the putt-putt. We're going to be going electric because we've got the good reactor. Next. We consider the RD-185, but that is 3.3 meters long and it's 1.3, and it's not quite as much thrust as the X-Core engines produce. It's lighter, but let's go on next, please. There's the 5M15. Now on the stand, they ran it for 3, 4, 5, 6 hours at 15,000 pounds of thrust. All I'm calling for is 3 of them, and they can adjust it all. They can adjust the pressures, and they can put up well up into the 23,000 pound range. But they're going to build a big nozzle because we're at only 600 pascals. And this is probably only 1.5 feet long. It's ridiculous. The next please. The engine with the nozzle and the pump and everything, one engine, flight ready, flight weight is only 500 pounds. Next, please. There's one of their, this is one of X-Core's thrusters. It uses alcohol, and I can't remember what. We might use these as opposed to the small Draco or Draco thrusters because we're not going to be doing that much work, at least with just the capsule itself, as it were. Next. There's a picture of it firing. And next. Okay, I didn't see what anyone was recommending for type of compressors. The thing that I know that can really pull a lot of air is either an axillary or a centrifugal compressor. The reason why I would recommend this is because we could downstream, if something got clogged up here, a series of filters, we can do a bypass and just shut it off and it'd go out. And we could run this in reverse and probably, hopefully get some, if we had a real clog, because I know dust is a problem. So I would recommend this next. I would recommend this as opposed to the axle, circumferential. Next. Okay, this is the very base. There's the truck. You see the 4 wheels. There's the reactor with the generator and the radiators on it. These are the fuel tanks. The Draco. I put smaller ones, and we saw the Super Dracos are running in pairs on the Dragon 2. I didn't know they were doing that. I don't know if we have to here, so we can go to next though. But that's the okay. Here's the thing that it allowed its concept. I spoke with Dr. Zubrin yesterday about it. I guess the concept is proven and it only requires funding. This is the reactor itself, and these are heat tubes. This is how it exchanges. It doesn't have any fluid, and so it exchanges to I guess a boiler, and it makes a steam engine run. It turns the turbine. It only weighs 1,100 pounds, 1,200 pounds. All 3 units: the generator, the turbine, and the reactor. And it produces 100 kilowatt E, 400 heat. Next, please. Just this is just some math showing some of the problems you have with volume versus weight and size. Next, please. Just briefly. Some of the things we considered. Next. Okay. Shielding micrometeorites. Composite, Kevlar, aluminum, Nextel, titanium. With the titanium being pressure, if you're part of the pressure vessel. Next. This is what the original weighed. I have a handout that I've handed out now. We can go to the next one, please. Okay, if you look at your handout, Dr. Zubrin, do you have one?
Yes, I do.
Okay. We can see the rundown of the reduction in mass. And then the total. I went ahead and go total into pounds here. And, we're underneath without, we didn't have to worry about that 1,750 kilograms at all of the shroud. So it gives us 750 kilograms to work with, because we're under the launch payload limit of the Falcon Heavy, which is 29,101. And I think that's about it.
Falcon Heavy, or?
The Falcon Heavy launches 29,101 pounds to Mars. I don't know yet. There is a caveat with that. I don't know what speed it's. Is it ejecting? Do you know anything? Is it going at the right speed? Because I said that.
The Falcon Heavy, 52 tons total orbit, about 14 tons direct transforms, injection, something like that. I could look it up, but if I want.
Well, we need to achieve a certain, kilometers per second because it's a conjunction class. So I just want.
Yes, that's what
Okay.
I'm saying. The 50 tons to low Earth orbit is something like 14 to 17 tons transmars, depending on how fast you travel.
Okay.
But say 14 tons.
One thing to mention.
That'll give you 6 months.
Yeah. So that is your 28,000 pounds.
I'll see it.
Yeah.
Oh, the point. One thing here, I just wanted to say, all of this is going to be removed under here and put under a protective tarp, because all of this stuff, you've got a reactor in there, you've got the compressor, you've got your Sabatier reactor. The fuel tanks are going to be cut away, but they're still finishing materials. So even this hydrogen tank here is going to go away. One thing I forgot to mention is these are 3 fuel tanks there next to those engine belts. So you drain one and you put water in one, and as you go, you're going around because you've got to have a place to put your water as you go through cycles. So it's got 4 different tanks where you can cycle water, when you start breaking water apart, etc. So Kent is over
Is
there.
this your earth return?
This is the RV. Yes. Pardon me? Oh, yeah, but he's gone. Yeah, Kent needed Bob. He's got to talk to him now, right now. Any questions, comments, or anything? Yes, sir.
Okay, so what is the weight in Leo and the weight that comes back from Mars? Or the mass?
You're talking about the mass. I have this at you're talking about the engines and the tank and
Yeah.
it's 8 tons.
8 tons? So roughly 14 tons goes to Mars and 8 tons comes back.
Yes, and actually we used the rocket calculation, and it turns out we're going to have fuel left, and we could do a full thrust burn for a minute or 2, depending on boil off, and you're going to be able to slow down plenty. The other thing that's nice about it is the tank and the engines aren't really all that heavy unless you have fuel in them. So in fact, you could go ahead and rotate them both, and you could generate gravity. You could do the exact same thing as you do with the Hab on the way back. So it'd be nice to vet this thing and go through every number and do the engineering, but it seems sound. Everyone, we all know we need funding. Thank
If
you.
they go today, how long do you think it would take before that could fly?
I see. Well, you've got a lot of stuff coming from X-Core. You've got a lot of stuff coming from SpaceX, and you've got stuff coming from Paragon. I think Bert Rutan's group would probably build the superstructure, and I really don't know. I think it's very viable. I look at by the way, it holds this fuel tank here takes a whole 41 tons of fuel in here. So that's where you get the full burn. It's a 48,000 pound burn you correct for Mars gravity, and you get a 1.18 thrust weight ratio on liftoff. And of course, it accelerates faster because you're burning off more fuel. And it's a direct liftoff to trans-Earth injection. You go right out. And you have residual fuel based on our calculations.